Okay, so next we have question 4. A right circular cone with perpendicular height h centimeters and radius r centimeters has a slant height of 20 centimeters. 4.1. Express the radius of the cone in terms of h. So we can see our diagram on the right hand side here given. We see our little triangle drawn there with r on the top, h on the right hand side, and s is our slant height, which we can replace with 20 centimeters now. So I've just redrawn this triangle on the left hand side here with my r, my h, and my 20 as my slant height. Important here to note, my 20 is opposite my right angle, so the side that's marked as 20 would be my hypotenuse in this triangle. Because it's a right angle triangle and because we want to solve for one of the sides, we can use theorem of Pythagoras here. So they want us to solve for the radius. The radius is one of the shorter sides, i.e. it's not the hypotenuse. So if we're solving for one of the shorter sides, we're going to subtract when we're using the theorem of Pythagoras. So our equation will become r squared is equal to 20 squared minus h squared. So it's the hypotenuse squared minus the other side squared. Reason there is theorem of Pythagoras. So if we just open that out, r squared will equal to 400 minus h squared. If we square root both sides, we'll end up with r is equal to the square root of 400 minus h squared. Okay, now 4.2. Show that the volume of the cone is given by v is equal to 400 over 3 pi h minus 1/3 pi h cubed. Okay, so because they're asking us specifically here for the volume of a cone, we need to know what the formula for the volume of a standard cone is. So the formula for of a cone is v is equal to 1/3 pi r squared times h. We're going to substitute whatever we can into this formula to try to get it to become the formula that they want there. V is equal to 400 over 3 pi h minus 1 over 3 pi h cubed. So the first thing we can substitute here is our r value, because in 4.1 we did work out r to be the square root of 400 minus h squared. So if we do that substitution, we'll end up with the v is equal to 1 over 3 pi into the root of 400 minus h squared. And because r is squared in the formula, we need to square that bracket and multiply by h at the end there from the formula. When we're opening this out here, before we open this out, we can, you see the square and the square root there can cancel each other off. So if we just rewrite that with the cancellation, you'll see that we have v is equal to 1 over 3 pi into 400 minus h squared times h. And that h at the end we can bring to the front of that bracket, because it will just make our distribution later a little bit easier. So if we bring that to the front, we'll end up with v is equal to 1 over 3 pi h into 400 minus h squared. Now we can distribute. We have two terms on the inside of that bracket. So we'll distribute the outside term, 1/3 pi h, into the bracket there. So multiply by the first term in the bracket, you'll end up with 1/3 pi h times 400, which is 400 over 3 pi h. And for the second term, 1/3 pi h times negative h squared will give you negative 1/3 pi h cubed. And that's our final volume there. And if you check with the question, that's exactly what they wanted. 4.3 now. Calculate the height of the cone for which the volume is at a maximum. Key words here, volume and maximum. Whenever in calculus they're asking you to find the maximum or minimum, they are asking you here to find the derivative. The derivative of what, you may ask? They want the maximum volume here. So we're going to take our volume equation, which is the answer from 4.2, and we need to find the derivative of the volume equation in order for us to work out its maximum. So the derivative of the volume equation from 4.2 will be as follows. V prime will equal to 400 over 3 pi minus pi h squared. Now that derivative you need to equate to 0. So we'll end up with 0 is equal to 400 over 3 pi minus pi h squared. And they want us to calculate the height now. So we need to isolate h. Our h term there is negative pi h squared. If I take that term over onto the left-hand side, the negative pi h squared will become positive pi h squared, and that will equal to 400 over 3 pi on the right-hand side. If we divide both sides by pi, we'll end up with h squared is equal to 400 over 3 pi all over pi. Those pi's can cancel off, so you'll be left with h squared is equal to 400 over 3. To get h, which is the height, you need to find the square root of 400 over 3, and that will be your answer.